Okay, the final result is 3 minus 1, which is 2, times 4 divided by minus 9, which is minus 8/9. Okay. Question 2. Simplify the following expression. Okay, all we need to do is to put the same terms together. Okay, first we put all ABs together, which is 3AB minus half of AB minus AB. And second, we put all the CDs together. Which is 2CD minus 4CD, right? And finally, we put all the constants together. Okay, we have 3/2 and a 3 and a 2. Okay, and then we try to merge all the terms. First, we have 3/2 AB. Next, we have minus 2 CD. Next, we have 13/2, right? Okay, any questions? No? Okay, let's see the next one. Question 3, simplify. There are two terms. I'll scroll up, okay. Okay, next one, simplify the following. Okay, this expression has two terms, right? By observation, the first term can cancel some ABs, and the second term can cancel some X, Y, and Z. So let's first try to cancel some ABs in the first term. Okay, the coefficient, this is 2/7. 21 is 3/7, right? So we can cancel a 7 here. For A, cancels A square. There is A left in the denominator. And also we can cancel B to 3 times, which leaves us B to the 4 times in the denominator. Okay. As to the second term, minus 2 minus 8 cancels, which we have 4 here. And X to 3 times cancels with each other. Y to 5 times cancel with Y to twice, which leaves us Y to 3 times. And cancel Z, we have Z to the twice here. So the result would be 2/3AB to 4 times plus Y to 3 times and 4Z twice. Right? Any questions? No? Okay, let's see the next one. Question 4, simplifies a product. Okay. By observation, to simplify this product, it's better for us to simplify each term first, right? Because first term, we can cancel a 2 on both the denominator and the numerator. So here we left a 2, here is 1, here is 4, right? And the second one, we can cancel an x here, which left us an x here, and 2y here. So first step, we have x plus 2y over 4, right? On the second term, we have 3y x plus 2y, right? And we can cancel x to y here. So the final result is 3y over 4. Okay? Any questions? Okay, no? Okay, let's see question 5. Write this expression as a single fraction. Okay, write something as a single fraction. All you need to do is to find a common denominator, right? But sometimes it's better to simplify each term first, which can make the question easier. Okay, so first step, we try to simplify each term first. The first one, we can cancel a to 3 times, which left us to b 2 over b, right? And the second term, we cannot do anything about it, so just leave it here. Okay, next, we can cancel 3 for both the numerator and denominator, right? So left us 2 here, 2 here. The third term would be b minus 1 and 2ab minus 2a. Two 2ab minus 2a, we can factor it. Actually, this one equals to 2a b minus 1, right? So b minus 1 cancels with b minus 1. So the third term can be rewritten to 1 over 2a, right? So this one looks much easier than the original one. And then we need to find the common denominator. Common denominator of these 3 terms is 2ab times a minus 1, right? So the first term becomes 2ab a minus 1. Denominator, so the numerator is 2 times a times a minus 1, right? And the second term becomes, okay, we use same common denominator. And the numerator becomes 3b times 2 times a, right? Okay, the third one becomes 2ab a minus 1 in the denominator. The numerator is 1 times, okay, we have already have 2a here. So times b times a minus 1. Sorry, I missed the b here. Okay. And now we can write this expression as a single fraction. The denominator is 2ab times a minus 1. And the numerator is, okay, first term 2, sorry, I missed a 2 here, right? So the first term would be 4a times a minus 1. Second term is 6ab squared. Okay, last term is b times a minus 1, right? So this is our final result. Oh, and notice that both of the denominator and the numerator has a minus 1, right? So again, we can cancel, sorry, not cancel this. Second term won't have this. Okay, it's not over yet. Actually, you can leave it here or expand the numerator to 4a squared minus 4a plus 6ab squared minus ab plus b. Divided by 2ab a minus 1. Okay, but it's okay. I think it's okay to leave it like this. Both of them are okay. Yeah, both are okay. All right. Any questions? Okay, if you have no questions, let's move on to the next one. Solve the equation ax plus bc equals to 3c minus 2d squared x for x in terms of a, b, c, and d. That means a, b, c, and d are constants. X is the unknown that you want to solve. Okay, so we put all x's together and put all the constants together and try to solve x. Okay, so the original equation is equivalent to if we put all x here on the left hand side and put all the constants to the right hand side. Then this is also equivalent to a plus 2d squared x equals to 3c minus bc, right? And then we can solve x, right? So intuitively, we want to put this term on the right-hand side, right? For both sides of the equation, we can divide the equation with this term. But be careful, when you divide the equation, when you divide each term with an unknown, be careful, the denominator cannot be 0, right? So we need to discuss. Okay, there is a discussion here. Discussion. Okay, first, if a plus 2d squared is 0, okay? If this term is 0, that means the left-hand side is 0, no matter what value x is. And at the meantime, consider the right-hand side, and at the meantime, 3c minus bc is also 0. Then for any value of x, this equation holds, right? So under this situation, there are infinite solutions, right? Which means x could be any real number. Understand? This one is 0, this one is 0. No matter x is, the equation always holds, right? So that means x could be any real number. Okay, the second case, if a plus 2d squared is 0, but at the same time, the right-hand side 3c minus bc is not 0. That means left-hand side is always 0, but the right-hand side is not 0, right? So no matter what value x is, the equation cannot hold. That means there is no solution, right? Understand? Okay. Third, if a plus 2d is 0 and right-hand side 3c, okay, we don't need to discuss the right-hand side under this circumstance because all we need to do is if a plus 2d squared is not 0, we can put it on the right-hand side, right? Then under this situation, x is 3c minus bc divided by a plus 2d squared. This is our only solution, right? Okay. Any questions? Okay, I'll leave you some time to think about this question, okay? You need to discuss whether a plus 2d squared is a 0, because if you want to use it as a denominator, you always want to discuss whether this value is 0. If it is 0, you cannot divide any value with 0, right? So be careful with this. If you don't know this value, don't put it in the denominator because it could be 0. You need to discuss before you use it as a denominator. Okay? Okay. If you have no question, let's move to the next one. Question 7. Suppose R is -2, S is 6, and T is 3R minus 2S. Evaluate this expression. Okay, all you need to do is to put all these values to this expression, right? Okay, so T over R plus T over S is, okay, T is 3R minus 2S. 3R minus 2S divided by R plus 3R minus 2S. Okay, R is -2, right? So we put -2 here. And S is 6, we put X here. So the first term becomes plus S, plus second term becomes 1 over 2R minus 1 over 3S. We put R together and put S together. So put these two together, we have minus R. And put these two together, we have 2 over 3S, right? And then we put R and S into this expression. First term becomes 2. Second term becomes 2 over 3 times 6, which is 2 plus 4, which is 6, right? Any questions? No? Okay, let's move to the next one. Explain the expression. Okay, this is a simple one, right? All you need to do is to distribute this value into the brackets. First term becomes 2x to the 5 times y to twice. And the second term becomes 8x because the other terms are canceling with each other, right? Okay, any questions? Okay, next one. What expression must be subtracted from 2x minus 3y plus z to give 3x plus 2y? Okay. Okay, suppose we denote the required expression as uppercase A, right? And the question tells you that this expression subtracted by A is 3x plus 2y, right? And then all you need to do is to find A here. Okay, to find A here, A is actually, you can put this, the second expression to the left-hand side and put A to the right-hand side, right? So A is 2x minus 3y plus z minus 3x minus 2y, right? Because when you put any expression on the other side of the equation, the signs change. Okay, so A is, you combine all the x, you have minus x, and combine all the y's, you have minus 5y, and combine all the z, we have plus z, right? So this is the expression you're looking for. Okay, any questions? No? Okay, let's see the next one. Evaluate the expression here when x equals to minus y. Okay, all you need to do is to put this expression into the original expression and then try to simplify that, okay? So if we put x is minus y into the original expression, we have 4. The first term becomes y squared, right? Second term is minus y. Third term is 7. Okay, minus 2. First term is 2y squared. Second term is 4 minus 4y, right? Last term is 2. Okay, and then we can expand all the terms. 4y squared minus 8y plus 28 minus 4y squared plus 8y minus 4, right? And now we can cancel something. Okay, 4y squared minus 4y squared. These two cancels with each other. Okay, minus 8y, positive 8y. These two cancels with each other. So the final result would be 24. Right? Any questions? Okay. No question. Let's see question 11. Okay, factors of expression. Okay, by observation, we consider the coefficients and the latter terms separately, okay? For all the coefficients, 12, 24, 18, what is a common factor? Apparently this is 6, right? Because 12 is 2 by 6, 24 is 4 by 6, 18 is 3 by 6. So the common factor here is 6, right? So here we have a 6 first. And for the others, RST square, R square ST, RS square T. Okay, the common part is RST, right? So this is a common factor of all the terms. And what's left in the square? By distributive laws, the first term would be 2t, right? The second term would be 4r. And the last term is minus 3s. Okay, when you finish this step, it's better for you to verify the result using the distributive laws, right? Just try to recover all the terms to see if it equals to the original one, okay? If you recover, you can find first term is 12r as t squared. The second term is 24r squared as t. Last term is 18 minus 18r s squared t. Okay, this one should be equal to the original. Should be identical to the original one, right? If it is identical, that means the second step is correct. Okay. And we cannot proceed anymore. So this one here is our final result. Okay. Any questions? No? All right. Let's see the next one. Express 1 over a plus 1 over b plus 1 over c as a single fraction. Okay. Write something as a single fraction. Key point is to find the common denominator. common denominator of A, B, C is apparently a multiplication of ABC, right? So this one, the first term, if we multiply BC on both the numerator and denominator, we have BC over ABC, right? Because when you cancel these two, you have 1 over A, right? Okay. The second term is once the denominator becomes ABC, the numerator becomes AC, right? Because you multiplied the denominator with an AC, so you have to multiply the numerator with the same coefficient AC. Okay, and you can verify. You can also verify when you cancel AC here, the second term is 1 over B. Okay, following the same principle for the third term, if the denominator becomes ABC, that means you times a BC here, right? So you to keep it equal to the original term, you have to times the same coefficient to the numerator, right? So the third term becomes BC over ABC. Okay, you can also verify if you cancel BC here, this term, sorry, should be AB. Should be AB here. AB, right? You can also verify this. If you cancel AB here, you have 1 over C, which is identical to the original term. Then only if you have the same denominator for the 3 terms, you can combine them. Okay, denominator is ABC, the numerator is BC plus AC plus AB, right? Okay, pay attention here. Only if the denominators are the same, you can combine the numerators, such as 1 over 2 plus 1 over 3 is not 1 over 5, right? This is not correct. So the correct way to do this is 1 over 2 plus 1 over 3. First of all, you need to change it to the same denominator, which is 3 over 6, 2 over 6, right? Only when the denominators are the same, you can combine the numerators. Okay, this is the correct way to do it. Okay, any questions? No? Okay, let's see the next one. Express this expression as a single fraction. Okay, following the same principle with the previous question, key is to find common denominator. Okay, so 3a minus 6. And 8b minus 16. Okay, first of all, let's see if we can cancel something on these two terms. Okay, apparently we can cancel, for the first term, we cannot do anything, right? There's no common part in the denominator and numerator. But for the second term, apparently we can cancel a 2 here, right? We can divide the numerator with a 2 and at the same time divide the denominator with a 2. This value does not change. So if we cancel 2 on the second term, we have the original expression changed to this one, b squared minus 2b divided by 4b plus 8, right? So we cannot do anything here. Okay, next we need to find the common denominator. So the common denominator of these two is the multiplication of these two terms. So here the common denominator is 3a minus 6 times 4b minus 8. Okay, so the first term, we need to times this term with 4b minus 8, right? The second term, we need to time it with 3a minus 6, right? Okay. It's better for you to verify this before you proceed to the next step, right? So for the first time, if we cancel these two, what's left is here. This one is identical to this one, right? So the second term, for the second term, if we cancel these two parts, what's left is here, which is identical to the second term, right? That means this step is correct. And then you can proceed safely. Okay, so next, we can expand the numerator to this. Okay, all you need to do is to be careful and be patient, because this is a long expression. It's easily to miss something. 3a minus b minus 6 and b plus 2. Okay, the only thing we can combine here is this term, minus 16ab and minus 6ab, and others we cannot do anything about it, right? So final result is okay. This is our final result. It's okay if you put 4 into the brackets. That means you can either write it like 4b minus 8. That's okay. 4b minus 8. Okay, any questions? No? Okay, let's see the next one. Simplify the fraction. Okay, a ratio is divided by another ratio. Okay, here we need to use this knowledge. A over B divided by C over D is actually A divided by B times D over C, right? Okay. That means when you see a ratio is divided by another ratio, this expression equals to the numerator times the reciprocal of the denominator, okay? So A over B here is unchanged times the reciprocal of the denominator. Okay. Okay. So following this rule, the original expression becomes, okay, we can write the denominator here times the reciprocal of the, sorry, we can copy the numerator here and then times the reciprocal of the denominator, which is over this one, right? And then we can try to cancel something. Okay, for the first term, we can cancel a 3 and R and then a T. Okay, for the second term, we can cancel a 2 and a R and a T squared. Okay, and let's proceed to the next step. Okay, 4t minus 2r, we can factor it to 2t minus r, right? Then we can cancel RT squared, which leaves us R here. And 2t minus R cancel with this 2t minus R, which gives us a minus 1 here. So the final result becomes minus 2 by 2 is 4, right? Okay, we have a 3 here and R here. All right. Okay, any questions? No? Okay, let's see the next one. By what fraction can we multiply 3x cubed over 2y 5 times to get 6y squared over 5x squared? Okay. We use the letter A to denote the required fraction. Then A is what you want to have, right? The question tells you that if you times this term is A, you can get 6y squared over 5x squared, right? Question becomes find value of A. So A here is 6y squared divided by 5x squared. Divided by, if we divide both sides of the equation with this term, you can find A, right? So here, we use the same knowledge in the question 14, right? Which is 1 over A over B divided by C over D is actually, you can transform the division to a multiplication, right? Which is A over B times the reciprocal of the denominator, which is D over C, right? So here, the division becomes a multiplication between these two terms, which is, we cancel a 3 here, we have a 4, y to 7 times. For the denominator, we have 5 times x to 5 times. Okay, any questions? Okay, so this is very important. Okay, if you have no question, let's see the next one. If x is a over b, with a is not equal to b, and b is not 0, then express a plus b over a minus b in terms of x. Okay. If you want to express this expression in terms of x, this one should be something x, right? Something x means you have to convert a or b to something x. Okay, and consider what it tells you already. X is a over b, so we can express a using bx, or express b using a and x. Both are okay, right? So if we want to express a using b and x, okay, because b is not 0 and x is a over b, so we can easily times b on both sides of the equation. which gives us bx is a, right? And insert this into this expression. We have a is unchanged. A is bx, right? So a can be substituted with bx. B is unchanged. A here again can be substituted with bx, and b is unchanged. Okay. Again, because b is not 0, so we can cancel a b on both of the denominator and the numerator, right? This gives us x over 1 divided by x minus 1, right? So this means the original expression is converted to another expression in terms of x. This is your final result, right? Okay, any questions? No? Okay. Okay, for the last two questions, please pay attention because these two questions are not very easy to think about. Okay, for question 17, for what value of a does equation 1 over 1 plus 1 over x is a have no solutions for x? Okay, if you want to discuss for what value of a does the equation have no solution, it's better for you to solve the equation first. And then we can see what value of a can make the solutions not exist. Okay, so first of all, there is some unknown value x in the denominator, right? So first of all, it's better to explicitly write the domain first. We have discussed this in our last assignment, right? Do you know what a domain is? Domain is all possible values that x can be, right? So the domain is x could be any real number, but x cannot be 0, right? Because x here is a denominator, so x cannot be 0. And also, this expression cannot be 0 because this expression is also a denominator, right? Okay, 1 plus 1 over x cannot be 0. That means 1 over s cannot be minus 1. That means x cannot be minus 1, right? So we rewrite this to x cannot be minus 1, right? Because x is minus 1, the whole denominator here is 0. That cannot happen because 0 cannot be a denominator. So the domain here is x could be any real number except 0 and minus 1, right? Right? Okay, this is very important. So if we make this clear, next we can try to solve this equation. The original equation is here. This is equivalent if we times x on the numerator and at the same time times it onto the denominator, we can have x over x plus 1 is a, right? And to solve this, you can put the denominator on the right-hand side of the equation, right? So this equation is equivalent to a times x plus 1, right? And then because you want to solve x, so you need to put all x's together. So the last equation becomes x equal to ax plus a, which is equivalent to, if I put ax on the left-hand side, it becomes 1 minus a times x equals to a, right? And then you can see from here, you can solve x. Intuitively, you want to put this on the right-hand side. You divide both sides of the equation with 1 minus a, right? But be careful, because again, you want to put an unknown value onto the denominator. You need to discuss whether this value is 0, right? So the discussion is here. You need to discuss. If you want to solve this equation, you need to discuss whether a minus 1 is 0. Okay? If 1 minus a is 0, that means a is 1. If a is 1, the left-hand side is always 0. Right? Left-hand side is always 0. And the right-hand side is always 1. No matter what x is, there is no solution, right? So first of all, if a is 1, there is no solution. Okay. Second, if a is not 1, then we can divide both sides of the equation with 1 minus 1, right? So the solution here is a over 1 minus a, right? So plausibly, this is your solution here. How to make no solutions for x? Okay, remember that our domain is here. X cannot be 0, and x cannot be minus 1, right? So if we can make this value to 0, or to make it equals to minus 1, that means the solution of x is 0 or minus 1, which is contradictory to the domain. That means there is no solution either, right? So the takeaway here is, if we let a over 1 minus a is 0, or to make this value equals to minus 1, there is no solution. Because it contradicts with the domain, right? Okay, I'll write it here. Because otherwise it contradicts with the domain of x. Okay. When 1 over 1a, so from the first expression, we can find a is 0. From the second equation, we cannot solve an a, right? Because here it gives us a equals to a minus 1. This cannot happen, because when you cancel a here, 0 is minus 1, which cannot happen. So the second expression has no solution. So that means we can only solve the first expression, which gives us a is 0, right? So the conclusion is when a is 1 or a is 0, there is no solution for x. Okay, any questions? Any questions? No? Okay. Let's see the last one then. The method to solve the last question is very similar to the previous question. So first of all, we need to discuss the domain. Okay, because x plus 3 cannot be 0. That means our domain is x could be any real number, but cannot be 3, right? This is our domain. Okay, next you can try to solve x. Okay, original 6x minus a divided by x minus 3 is 2 is equivalent. We can put x minus 3 to the right hand side of the equation, which is 2x minus 6, right? And this is equivalent to, because we want to solve x, we can put x together. This one is 4x equals to a minus 6, right? And then x can be solved to a minus 6 divided by 4, right? This is our solution. How to make it have no solution for x? Because x could be any real number, but cannot be 3, right? So to make it no solution, the only thing you need to do is to make this value to 3, right? When this value to 3, that means your solution is x equals to 3, which is contradictory to the domain. So in this case, there is no solution. So to make it no solution, let this value to 3. That is, a is 3 by 4 plus 6, which is 18, right? That means when a is 18, the solution is x3, but your domain indicates that x cannot be 3. These two statements are contradictory with each other. So when a is 18, there is no solution for x, right? So the conclusion is when a is 18, there is no solution. If it's not, if it's still not obvious to you, you can try to verify this, right? Okay, when a is 18, let's put this value into the original equation. The numerator becomes 6x minus 18. The denominator is x minus 3 equals 2, right? This is when you try to solve this equation, it gives you this one, right? And it equals to 2. When you cancel this 2, which gives you 6 equals to 2. That is not wholes, right? So this verifies that when A is 18, there is no solution for X. Okay, remember, you can always verify your answer. Okay, this is very important. When you have done something, and if you still have some time, you can always verify your answer. Okay, in other words, when you solve a value of A and put it in the original equation, and then you solve the value of X, that means there is a solution, right? That means the value of A you get is not correct. Okay, only in this way you can find there is no solution. That means value of A you get is correct. Okay, remember, you can always verify your answer. Okay, any questions? No? Okay, this is all the questions in assignment 3. And after this class, I will give you assignment 4. Okay, because you have done many mistakes in chapter 1 to 3. So in next assignment, I will assign some questions in chapter 1 to 3. Okay, let's do some questions in chapter 1 to 3 again. And in the future assignment, the plan is to spend two assignments per chapter.